This is section 2.1, part D, describing location in a distribution. So when you are exploring quantitative data, the first thing you should do is always plot your data. Make a graph, usually a dot plot, stem plot, or a histogram. Then you need to look for the overall pattern. You're looking for the shape, the center, and the spread, and you're looking for any striking departures such as outliers. Next, you need to calculate numerical summary to briefly describe the center and the spread. And then sometimes the overall pattern of a large number of observations is so regular that we can describe it as a smooth curve. If we can describe this as a smooth curve, we will use a density curve. This is a curve that shows probability. The area under the density curve is equal to 100% of all probabilities. As we usually use decimals and probabilities, you can also say that the area is equal to 1 because 100% as a decimal is written as 1. A density curve is a curve that is always on or above the horizontal axis, and it has an area of exactly 1 underneath of it. A density curve describes the overall pattern of the distribution. The area under the density curve and above any interval of values on the horizontal axis is the probability of all observations that fall in that interval. Density curves, like distributions, come in many different shapes. A density curve is often a good description of the overall pattern of a distribution. Outliers, which are departures from the overall pattern, are not described by the curve. You should note that no set of data is exactly described by a density curve. The curve is an approximation that is easy to use and accurate enough for practical use. So when you are looking at a density curve, the median of the density curve is the equal area point. So this is a point that divides the area under the curve in half. So half the data will be to the left of the median, half of the data will be to the right. The mean on a density curve is the balancing point at which the curve would balance if it was made of solid material. The median and the mean are the same if this is a symmetric density curve. They will both lie at the center of the curve. If we have skewed data, the mean of the skewed curve is pulling away from the median in the direction of the long tail. So if your data is skewed, the mean will always be closer to the tail than the median is. Because a density curve is an idealized description of a distribution of data, we need to distinguish between the mean and standard deviation of a density curve and the mean and standard deviation computed from the actual observations. So for the actual observations, we're going to use a mean as x bar and a standard deviation of s of x. But on a density curve, we're going to say the mean is mu and the standard deviation is sigma. You may notice that we use the same notations for mean and standard deviation of an entire population in Chapter 1 of mean and sigma, as we do for the mean and standard deviation on a density curve. We can roughly locate the mean, mu, of a density curve by I as the balancing point. There is no easy way to locate the standard deviation sigma by I for a density curve in general. So explain why this is a legitimate density curve. We know this is a density curve because the entire curve is above the x-axis, and we know the total area under the curve is 1. About what proportion of observations lie between 7 and 8? So between 7 and 8 is this area right here, and the graph indicates this has an area of 0.12. This is a percent, so we know about 12% of the observations lie between 7 and 8. We need to copy the density curve, and then we need to mark the approximate location of the median. Now, our median is located so that half of the data is to the left and half of the data is to the right. So if we draw this red line, about half of the data would be to the left of it and half of the data would be to the right. So the red line is approximation of the median. Now to mark where the mean is located, because this data is skewed to the left, we do know that the mean will be to the left of the median. So if our median is the red line, we can estimate our mean to be the blue line. That would be the point where if I were to put a fulcrum under it, it would balance out the two sides of our graph, and the mean is always going to be pulled towards the longer tail.